In this video, we are going to discuss methods and everything you ever wanted to know about methods but were afraid to ask. So the first thing to say about methods is, why do we have methods? Why don't we just write all of our code in one big long line inside of C# or Java? And the answer is because frequently you're going to want to do the same thing over and over again, and it would be nice to be able to call that. That's one reason. The second reason is it turns out that parts of our code is going to be about doing one thing, and then part of our code is going to be about doing some other thing. So, for example, let's say you're going to ask the user to calculate calculate the area of a circle using pi and the radius that they give you. So you might need to do this multiple times. Like, for example, if you're doing some kind of graphics routine where you're going to have to do something with circles the whole time, you may need to be able to calculate the area of those circles over and over and over again. So it's really silly to rewrite the same code multiple times. And so what you do is you put that together into a method. Now, if you're familiar with object-oriented programming, you might be thinking, but isn't that the definition of a class? Isn't that why you have classes, so that you can put stuff together? And the answer is yes. But even within classes, you need to organize your information or your code such that it's easy to find. It's nice to be able to give it a name. So rather than saying, something like area equals math.pow radius 2 times math.pi, and having that over and over and over again inside the code, it would be nice to be able to say calculate area and then give it a radius. And so effectively, a method allows you to define a new thing that your code is then allowed to do. And then you call that new thing whenever you need it in the future without having to ever rewrite it again. So 3 main reasons for doing methods. The first is it makes it cleaner and allows you to organize your code. The second is it permits reuse of your code such that when you come back and you try to call that method a second time, you don't have to rewrite it or debug. And the third thing is it ups the quality of the code. So once you have written the method for calculating the area of a circle once, you don't ever have to rewrite that again. Even if you're in a completely different project 6 months later at your work, and now you suddenly need to calculate the area of a circle, why would you rewrite it? Just go pull your code from the old method. You don't get points for redoing the same thing over and over again. As a matter of fact, we would mostly prefer that you don't do that. You take things that are already there and use them rather than reinventing the wheel over and over again. Okay, so that's why we use methods. They are a way of putting stuff together and giving it a specific name in a nice, organized fashion. You might ask yourself, well, how am I supposed to know when I should put something in a method? And the answer is, anytime that you have a block of code that's doing one thing, it should be a method. So if you're going to prompt the user and ask them for, choose from the following menu: 1, calculate area of a circle; 2, calculate area of a rectangle; 3, calculate area of a triangle. That asking them and reading in their answer might be one method. The actual calculating the area of the circle would be one method, calculating the area of a rectangle would be one method, and calculating the area of a triangle would be one method. So in total, I just described probably 4 methods. You could make an argument that just printing the menu should be one method, and reading in the user's input might be another method, and that would be valid as well. There's no one right answer as to when you should have a method, but the thing you should always be asking yourself is, am I likely to reuse this code? If the answer to that question is yes, that this could come up again in the future, it should be a separate block. And the other thing is it more readable if I make it into a separate block? And the answer is probably yes. So don't ever be afraid to make lots and lots of methods. I would prefer that you err on the side of making more methods than not enough methods. You shouldn't have a big long pile of code as one method, and it does 12 separate things. That's really hard to maintain and debug. So what you should have is lots of smaller methods that each individually do one thing. You'll sometimes hear people say that no method should ever be more than 2 pages of code. I don't know about that. So once in a blue moon, you'll end up with something that's just really complicated, and it turns out that you're going to need more than 2 lines of code, 2 pages of code. But in general, it should only do one thing. So that's why we do methods. They are a good thing. You definitely need to do methods. I will say that from this class in previous semesters, I have noticed that this is a topic that people strangely get confused with compared to objects. So we're going to go through how you define a method and why you have the layout of a method. There are some very specific things that you're always going to have, and that's what we're looking at on this slide on the screen. So every method is going to have a return type. It may be that the return type is nothing, and that's okay, but you still have to specify what the return type is. So this part is never negotiable. There will always be a return type. It will either be int, double, float, string, void, which means it returns nothing, or maybe it's an object like a dog or a car or an area or a square or some other object that you have defined. But every method must have a return type. If you are not going to have anything returned from the method, then it is a void method. It does not return anything, and you would specify void as the return type. The second thing you must have is a name. So every method has to have a name, and it should be a lowercase name. You should not be capitalizing the name in either case, and it just tells you what the method is doing. You should be very helpful with your naming. You have to bear in mind that right now you're writing code for you because you're trying to get through class. Okay, you're writing code for you and me, effectively, or whoever has to grade your test. But in the real world, you're writing code for a company, and the chances are you're going to write that code, and then you're going to move on to some other project, and some poor schmuck is going to come behind you and have to actually read and understand your code. So if every one of your methods are called x7, q19, and b3, they will have no idea what those methods do. By comparison, if you name it calculate area of circle, they will fully understand what it is. So longer names, or at least more descriptive names, are important. Don't just use X and Y. You will see me sometimes do that just because I'm explaining a very simple concept, but your method name should be a clearly defined name that anybody would understand what that method does just from the name. And sometimes you'll start writing it and realize, it actually is going to do this other thing, and that's okay, just rename it. And don't be lazy, go back and rename it and fix it all over your code. Don't have a method that says calculate area of circle, and in actuality it calculates the area of a square. If you do that, we will all hate you, because the next person who has to look at your code is going to spend a day debugging that, wondering why this method is not working and doing what it's supposed to do, and then when he fixes it, a whole block of other code is going to break because it's expecting it to calculate a circle and it's actually calculating a triangle. All right, so enough about all that. So every method is going to have a return type, it's going to have a name, and then it's going to have a set of parentheses. The parentheses are not optional. And let me be really clear about this, because this is something that people get confused about all the time. If I create a variable inside of my code, so like I say int x, I know I'm doing a single variable name, that does not get parentheses because it is a variable. Variables do not get parentheses after their names. If, however, I say void doStuff, and it has parentheses, then I am inherently writing a method. The method will then have curly braces, which I can never draw, so they're going to look like those, and that is the outline of a method. The void is the return type, which in this case is nothing, so it returns nothing. doStuff is the name of my method, and this is where the parameters go if there are any. Even if there are not, you must have the parentheses there. Without the parentheses, you are not defining a method, you're defining a variable. So if you see this, it says void doStuff, that would be like defining a variable of type void called doStuff. And then these curly braces are very confusing to the compiler because it's like, I don't know what you're trying to do here. Maybe you're trying to make setters and getters if you're in C#, but no, I really don't know what you're doing here. Also, you really can't make a variable of type void because that doesn't make any sense. So this will cause confusion if these parentheses are not here. And I will tell you from grading tests in previous semesters, I see people all the time forgetting to put the parentheses there or putting parentheses where they shouldn't be, like here. So again, variables do not get parentheses. Methods always have parentheses. There may be nothing inside the parentheses, or there may be stuff in there, but the parentheses themselves must be there. All right. So what goes inside those parentheses? And that's what are called parameters. This is information that you're giving into the method that the method is going to use, as opposed to the return type, which is information coming back from the method after it completes. The body of the method is where you're going to do all of your calculations. Okay, so again, to review, the return type indicates what's coming back. The return is going to be the actual value that the method is giving you. There's also a return statement that you may write inside of a method. This is a method of saying, this is a way of saying, I now wish to return this value. If you call the statement return inside of your code, that method ends immediately upon calling return. So if you say return 7, right there and then the method stops and returns 7. It doesn't execute any code that is past that point inside the method. So that's something to be aware of. So the return type and the return statement are two different things. They are related because the return statement must return a type of the type that was declared as the method type. All right. If you're not returning anything, you'll return void, and the expression must conform to the return type. Yes. A common error that you're going to get from the compiler is method declared to return an integer, but no integer returned, or something that's vaguely like that. If you say that the method is going to return an integer, at some point in there, you better return an integer. Otherwise, the compiler is going to complain at you. If you say the method is returning a void and you try to return an integer, the compiler is going to complain at you. You have to be consistent. Whatever you say it's going to return, that is what you better return. So make sure that you understand that. So I'm going to go through a couple of quick examples over here. I pre-wrote these just before I recorded the video, just so that you don't have to watch me type, but I'm going to go through what's happening here. I'm going to show you the Java first, and then I'll do the C#. Their URLs are at the top. If you want to pull up the C# one right now, that's the URL for C#, and this is the URL for Java. They're almost the same code, but of course, there's a couple of minor syntax differences. So let me explain what I'm trying to do here in this code. So I mentioned calculating the area of a circle. If you remember back to some math class a billion years ago, somebody told you that the area of a circle is defined as pi r squared, where r is the radius. So we need to take in a radius, we need to square it, we need to multiply that by pi, and that is the area of a circle. I hope. If that's not true, then don't complain. All right, area of a circle is going to be a method, because I may need to do this more than one time. So over here, I'm going to define a method. Now, the part that I've highlighted is pretty much identical in both of these blocks of code. So that's the Java, this is the C#. You're going to see that they both say the same thing. There are two words here that I did not talk about previously, and that's intentional. For right now, anytime that you are writing a method inside of your main class, whether it be your main class or your main class, you're going to always write public and static before it. If you forget either of those words, you will get a compile error. Very specifically, if you forget the word static, it's going to tell you a static method can only call a static method. If you forget the word public, it'll probably work, just depends on the circumstance. So in general, for right now, you're always going to write public static before you write a method name. I will explain why both of these words exist at some point in the future in another video, probably a video 3 or 4 in a minute. But you will always put them in here when you're dealing with a single method like this, or a single class like this. All right, so ignoring public and static, the next thing that is in here is the return type. I'm going to return a double because I know that this is going to produce, in most cases, not an integer, some kind of floating point number, and I want it to be nice and precise. So I'm returning a double. The name of my method is circle area. Could have called it calculate circle area or calculate area of circle or whatever. The name of this, you'll notice that there's some style syntaxes here. So different people and every company that you work at will have a style guide where they will tell you how they want you to write variable names and how they want you to write method names, and you will have to conform to that. And unfortunately, it'll vary from company to company. There are lots of acceptable ways to do things. Usually, method names do not start with a capital letter because object names do start with capital letters, and if you have a global variable, often you'll put it in all caps, and that's just so that it's a little bit easier to tell what's going on at a quick glance. So method names generally will start with a lowercase letter. What happens after that is you're probably going to have multiple words in your method name, and so when you want to put those words together, there's a couple of options. Either you can use an underscore, which is what I did in this case, so circle underscore area. It has to be one word, you can't use a space, so the underscore is a way of cheating that. That's a very common way to do it. Another common one is to use a dash, although that's less common than an underscore because it's a little harder to read. And then the other one is what's called camel case. And in that case, the first letter of this is going to be lowercase, but every other word will begin with a capital letter. So if I was doing this in camel case, I would have said something along this line, something like that. And that just has a lowercase c and a capital A, and now you don't need the underscore. You will have some people who will tell you to put the underscore in as well. There's a whole bunch of different options. Honestly, the only thing I will tell you right now from the standpoint of this class, and in general from being a good coder, is just be consistent. Don't change in the middle of your code from the underscores to the camel case to something else. That looks awful and it's really hard to read. So make sure that you're consistent with yourself as to what you use, and then it'll be okay. For this class, there's no right answer. We're never going to grade you wrong for the choice that you did. You need to choose a good method name, but it doesn't have to specifically have one of those style syntaxes. All right, so that's the method name. And then the last part here are the parameters. Okay, so let me explain what's going on with the parameters. When you define the parameters, you're going to give them a type, just like you do when you define a variable. And you're going to say double and then give it a variable name, which in this case I'm calling it radius. There can be more than one of these, and you obviously put them on the same line inside the parentheses separated by commas, and it'll always be a type followed by a variable name. It is important that you have an understanding of what's going on here. What this is doing is it's creating a new variable called radius, which is only going to be valid inside of this method. Once you are outside of this method, radius no longer exists. It just disappears, poof. The other thing that happens is when you call circle area, you now must pass it one variable, and that variable must be of type double. If you send it anything other than a double, you're going to get a compile error. Because again, it's checking to make sure that what you said you were going to take in is actually what you were given. So for example, if you read it in as an int and you try to pass it up there, you will either get an error or you'll at least get a warning about an implicit typecast. We're going to explain typecasting later on, but for now it's important to know that when you pass something from one place to another, the things that you're passing in and the things that you're getting back must be of the type that you specified, otherwise you'll sometimes get errors. All right, so public static because I said so. Double because I'm returning a double. Circle area is the name of my method, and it takes in one parameter, which is called radius, and it is of type double. The radius that is here is different than a radius that you may have down here in main. This is a completely separate variable, and it only exists for the point of, or for the duration of this method. All right, so here in my method, I'm going to do the calculation. This is a little bit goofy, and the actual syntax is almost identical between the two languages. The only thing that's different is that the power is capitalized, POW, in C#, whereas it's lowercase in Java. So what I'm saying is I will return, and this is a return statement, which causes the execution of this to end. This method will stop executing at the end of this statement, no matter what. Even if there's something below this, it will never get to it. And what I'm returning specifically is math.py, which is 3.1415. It's just a constant that is stored in an object called math. And I'm multiplying it by math.power, which is a method for calculating the power of a variable. And I'm taking in, it takes two parameters, one of which is called radius in this case. That's the radius that I got into my method. And the 2 is because I'm trying to square it, raising it to the second power effectively. So math.power is a method that exists. Very specifically, pow is a method that exists in the math object. We'll deal with all of that later on, but bear in mind this is just a method call. I'm calling pow, and I'm passing it two parameters, one of which is radius, which is of type double, and the other one is the power that I'm passing in, which can either be a double or an integer in this case. All right, so this will execute. It will take in a radius, it will multiply it out, raise it to the power, and it will return a value. So how do we actually use this method? So down in my main here, I'm asking them, please enter a radius, basically, and then I'm doing a read. When I do the read in Java, you'll note that I'm calling next double. You'll see, if you remember from the previous set of lectures when we were talking about the different read statements, there was next int and there was next line. In this case, I'm calling next double because the specific thing I'm trying to read in has to be a double. It has to be treated as a double. So I created a variable called radius, and I called next double, which pulls in a double and stores it inside of a variable named radius. Now, I want to point out that this radius down here is different than this radius up here. They have the same name, and that's very confusing, and bad enda for doing the same name in both places. It's perfectly syntactically valid, it's correct, however it is a little bit confusing here, because the radius that's down here is not in any way the same as this radius up here. It turns out that I'm going to pass the radius from down here into the radius from up there, so they will have the same value, but they are completely different variables. And there's going to be a whole section about that in the next video, or one of the next videos, talking about passing by reference versus passing by value. So if that didn't make sense to you, make sure you watch the pass by reference video in a few moments. All right. At that point, I call circle area, which is the name of my method. And again, remember, I have to pass it something that is a double, and my radius is a double because that's what I specified. And you'll note that it returns back to me a double, which I'm calling area. I can call it whatever I want, but that is going to be a double because the method returns a double. I now have an area and I'm printing it out. So let's run this guy and let's see what happens. So it's going to ask me how big is my radius, and I'm going to type in a number. And in general, when you're testing code, you should always do a basic sniff test to make sure that it's doing what you think it's doing. So if I pass it a 3 here, a radius of 3, if I square 3, I know that comes out to 9. And if I multiply 9 by pi, which is 3.14, then that should be about 27 plus whatever junk is off to the side. So I would expect that if this ever actually runs, which it seems to have gotten to the point that it's disconnected. So, hey, let's run over to the C# one and see if we can get it to run. It's disconnected as well because the world hates me. Let's see. I think my Wi-Fi has disconnected. That's why it's pulsating over there. However, we seem to be back. Okay, let's see who wins, Java or C#. Okay, Java 1. What's the radius? I'm going to type in 3, and 3 times 3 is 9, times 3 for 0.14 is around 27, and yeah, 28.27 sounds very plausible. Just to prove the point that in C# it works the same way, I get the same number, 28.274. It's a little bit more precise on one than it is on the other, and that's just by whatever the default is of how it prints. Okay, so this is a method. You will use methods all the time. You should name them appropriately. You need to always have a return type. You need to always have parentheses that specify what parameters come in. The parameters that are coming in, you can have more than one. They can be separated by commas. That's perfectly valid. And over time, you're going to write bigger and more complex methods. So I hope this clears up methods for you guys. And if you have any questions, always feel free to reach out and help. Thanks.